Okay, this is 9.5 homework. The first problem gives us this one right here. The nice thing is the way they wrote it, we can easily tell what B and A are. It looks like we're doing 1 over and then n times n plus 1. And this is sigma notation. Oops, sorry about that. This is sigma notation from n equals 1 to 221, because if you start writing this out, you know, our first term, n, is 1, and what we get here is 1 over 1 times 2 for a sub n. So your second term is 1 over 2 times 3, so you can see that, you know, we're putting n here each time, right here, and then the next highest term goes here. So we can write that, and then in which case we're going all the way up to 221, where that's our highest term number right there. So we're going up to 221 for A, and then B is this 1 over, and you're going to have to put this in parentheses, n times n plus 1. All right, we're skipping problem 2. Sorry about that. I did not mean to put that on there, and we're going to go on to problem 3. All right, compute the sum of the next formula. Now we can use our calculator for these. Another thing you can do is recognize that this is arithmetic, and we have a formula on the formula sheet. On the formula sheet, here's the formula. It's right here for a finite arithmetic series, because that's what this is. So here's our finite arithmetic series. The number of terms is 87. The first term here is what you get when you plug in 1, which looks like it's 1. And then a sub n would be a sub 87, the 87th term. When you plug in 87 here, multiply by 2 and subtract 1, you get 173. So you plug those in, you'll get the same number that you'll get if you do this in your calculator. And in your calculator, you do alpha window, and you're doing summation from, I'll use x, goes from 1 to 87 of this, which is 2x minus 1. Is our sequence, our arithmetic sequence. So the sum of that sequence is 7,569. Okay, the next one, our sequence is, the first term is 1, the second term is 2, third term is 3. So it's arithmetic where you're adding 1 each time. So you can use the finite arithmetic formula again like we used in the last problem off our formula sheet right here, where you have 63 terms. The first term is 1. The 63rd term is 63, and you can divide by 2. So it's pretty easy. It's basically the middle of these numbers, 1 and 3, times how many numbers there are. And you can also use your calculator by plugging this in like we did the last problem in summation notation. Either way, what you get for this is 2016. Okay, the next problem looks like an arithmetic series here. We're subtracting 3 each time. So the common difference is -3. Our first term is 8. And we're going all the way down to this term. So we could use the formula again for a finite arithmetic series, but we would need to find the number of terms, because we don't know. We know a sub n is -28, but we don't know what term number that is right here. So we don't know how many terms we're adding up. So that's what we have to find. To do that, we're going to write the formula for the sequence, which is a sub n, first term plus n minus 1 times the common difference. The first term is 8. The common difference is we're subtracting 3. And we know that a sub n in this case is -28. So we're going to put in -28 right here. And we're going to solve for n. So if we subtract 8, divide by -3, and add 1, we get 13. So that's the 13th term right here. So we can plug in 13 for n. So we end up with 13 times the first term, 8, plus the last term, -28. Divided by 2 here, and that gives us -130. All right, this next problem wants to find the sum of this sequence. This is arithmetic. We're subtracting 1 each time. So we can use the formula. The sum is equal to the first term plus the last term divided by 2, all times the number of terms. So the number of terms we don't know, so we're going to have to leave that as n. The first term is -8. The last term is right here, -9 plus n, all over 2. So you can enter that in. I guess you could simplify this a little bit if you made it -17 plus n over 2. So you can enter it in like that. That's probably the easiest way to enter it in. I mean, there's different ways to enter it in. You could do -17 n over 2 plus n squared over 2 as well. Either way, that or that are probably about the same. And that's all we can do, is just enter in this formula. All right, for the next one, I'm just going to plug this into the calculator. So do alpha window, do the summation notation 2, and just use x goes from 1 to 10 of this sequence. So make sure you use the right parentheses, and you should get negative 185. And I'm sorry, I put the first problem on there again, so I guess that's an easy point. But this was n, and then we had n plus 1. I think I used an extra set of parentheses in the bottom. You don't really need these parentheses right here. But yeah, it's an easy one. All right, next one, another one I would just use a calculator on. Summation notation. We're going from this case 0 to 22, and we're going to enter this in using extra parentheses, negative 1 to the nth power, or x power in my case, and then times 2x. I didn't need to put that parentheses, but oh well. And in this case we get 22. I left the 0 on the bottom there, but 22 is the answer. Okay, the next problem says a man gets a job with a salary of $35,000. He's promised $2,700 raise each year. So we can start writing this out. N and a sub n. The first year starts off with $35,000. The second year we're going to add $2,700 to that, and so on. So this is an arithmetic sequence. We want the total earnings, so we want the sum for the first 10 years of the sequence, and the sequence would be a sub n equals the first term plus n minus 1 times the common difference. So in this case the first term is 35,000 plus n minus 1 times the common difference, which in this case we're increasing by 2,700. So that's our formula. We can either plug that into the calculator, or we can use the finite arithmetic series formula on the formula sheet, which says take the first term plus the last term and divide by 2. The only thing we would have to do is find the last term here after 10 years by plugging in 10 into this formula right here. Plug in 10 there and you'll get a sub 10. That goes here. And the first term is 3,500 divided by 2 times 10 is the total number of years or terms that we're adding up. But I'm just going to plug this into the calculator and get the answer, and you can do the same. This next one's a pretty easy one. If you start writing out this sequence, you have n and a sub n. The first term is 1 for the sequence. The second term is 2. The third term is 3. And it's not hard to see that our sequence then is just n. Plug in 1, we get 1 out. Plug in 2, we get 2 out, and so on. So that means that if we're doing the sigma notation, we're adding up n as n goes from 1 to 88. So a is 88 and b is n. Okay, next one we want to find the sum of this. So this time our first term is 0, second term is 3, and so on. So I'm going to write a sub 1 equals 0. And also this is arithmetic where my common difference is 3. So I'm going to write the sequence formula, a sub n equals the first term plus n minus 1 times the common difference. And just fill this out. So the first term is 0. I have n minus 1 times the common difference of 3. There's my sequence. And the question is, I'm adding up how many terms? Well, let's plug in 42 for a sub n and find that out. So I'm going to distribute the 3 and get 3n minus 3. Add 3 and divide by 3, and you get 15. So this is the first 15 terms of this arithmetic sequence that we're adding up. So let me just write the sigma notation. N goes from 1 to 15 of this right here, the sequence, which is 3n minus 3, if you simplify it. You can plug that into your calculator, or you can use this formula, which is the first term plus the last term that we're adding up divided by 2. The total number of terms we're adding up we found out was 15. The first term is 0. The last term is 42, all divided by 2. Whether you do it this way in the calculator or with the formula, you get the same thing, 315. Okay, the next question says an auditorium has 50 rows of seats. The first row contains 80 seats. And then each successive row after that, you add 7 seats. So it'd be 87 and so on. Add 7, you get 94. So you can see that this is an arithmetic sequence, and this is how many seats are in row 32. So if we go down here to 32, let's just use the formula for arithmetic in this case, which is the first term plus n minus 1 times the common difference. First term is 80, n minus 1 times the common difference of 7. And in this case, we're going to plug in 32 for n, so we can find out in the 32nd row how many seats there are. Okay, you get 297 for that. All right, and then how many seats are in the auditorium? Once again, you're adding up all of them now, so you're going from n equals 1 to 50, all 50 rows of this sequence. So I could put 80 plus n minus 1 times 7 here. That would work. Or you can use the formula, which is n times the first term plus the last term divided by 2. The total number is 50. Adding up the first 50. The first term is 80. The last term we found was 297 over 2. So you can do this in your calculator or this. Either way, you get 9,425. Okay, this next problem I didn't mean to put on here again, so that's my fault. We don't have a way to do this at this point. You're going to do this in calculus next year. The only way we could do this really for now is just to plug in a really big number up here and I'll get an approximate. So if we add like the first 50 terms in our calculator, you're going to get 0.1 repeating, which is 1/9, which ends up being the answer. But later you're going to find a way to pull this apart into two geometric. There's a geometric in the top and geometric in the bottom, and you can do some simple algebra to find the sum of this series in calculus. But for now, we're just going to move on and do more simple ones like this one. We can find the first 11 terms of a geometric sequence if the first term is 4 and the common ratio is 4. So we're adding up from n equals 1 to 11 of this geometric series, which our geometric series is the first term times the common ratio to the n minus 1 on the formula sheet. So that'd be 4 times the common ratio of 4. Common ratio is -4 to the n minus 1. You could plug that into your calculator. We also have a formula for this on the formula sheet for a finite geometric series right here. We actually even used this in the last section. That formula is right here. It's the first term, a sub n, g sub n, whatever you want to call it. I'm sorry, a sub 1, g sub 1. So the first term is 4. We have 1 minus, and then this is -4 to the nth power, which would be 11 in this case, and then 1 minus -4. So if you simplify this, plug this in, start with the -4 to the 11th, and then do 1 minus that number times 4, and then divide by 5, which is what's in the bottom. You will get the answer that you're looking for, or you can do this in the calculator. Either way, right here, which would be 3,355,444. All right, the next problem is a geometric series again. We're multiplying by a common ratio of 2 over 7 if you look at this, because 7 times 2 over 7 gives you just 2. And then if you multiply 2 by 2 over 7, you get 4 over 7. So it's kind of easier to see from this point moving forward what the ratio is, but that's okay. It's 2 over 7. This is geometric now, so the first term is 7. Now, because our r is between -1 and 1, we have a simple formula that's on the formula sheet that works just fine for finding the infinite geometric series. It's the first term divided by 1 minus r. So that's the easiest way. It's the first term divided by 1 minus r to find the infinite geometric series. So the first term is 7 over 1 minus 2/7. Let's make this 7 over 7. So this would be 7 divided by 5/7, so multiply by 7 over 5 instead, and you get 49/5 as your answer. That's going to be the easiest way to do these. And this only works right here for when our r value is between -1 and 1. Okay, the last problem then gives us another geometric, and this one's a little bit disguised, so I'm going to rewrite it as 11 times 1/8 to the n. And now it might look more familiar as far as this part right here goes, because our r is 1/8 in this case, and our first term, g sub 1, is what you get when you plug in 1 here, which would be 11/8. So because our r is between -1 and 1, we can still use that formula. So does it converge? The answer is yes, it does converge. And so finding the value of the infinite geometric series, we can just use that same formula, g sub n over 1 minus r. First term is 11 over 8, and then 1 minus 1/8. This would be 11/8 divided by 7/8 if you make this 8 over 8, and multiply by 8 over 7 instead, and the 8's cancel, you get 11/7 as your answer. All right, hope this helps.